In our vast universe, among a stellar sea of stars, planets, and galaxies, there's a unique, vibrant speck of blue and green that stands out from the rest. That extraordinary jewel is our home Earth, a realm teeming with life, with its own rhythm, harmony, and balance. But today, Earth is teetering on the edge of disaster with our shared destiny swaying precariously, being held hostage by two simple words: climate change. They're words you've heard before. They've echoed through the halls of science, whispered in the corridors of power, and resonated in our collective consciousness. But what if everything you thought you knew about climate change was just the tip of the rapidly melting iceberg? What if the real story was buried, waiting our discovery beneath the deep layers of facts, figures, and forecasts? There are very few elements that are as fundamental to our understanding as greenhouse gases, the primary driver of modern-day global warming. The accumulation of these gases in the Earth's atmosphere forms a sort of blanket, trapping heat and causing the planet's average temperature to rise. This phenomenon is commonly known as the greenhouse effect. The Earth's atmosphere consists of several greenhouse gases. Carbon dioxide is one of the most prominent, largely due to human activities like the burning of fossil fuels and deforestation. As of 2021, data from the National Oceanic Atmospheric Administration showed that the atmospheric CO2 concentration was over 410 parts per million, a level not seen on Earth for millions of years. This represents an increase of more than 47% since the start of the Industrial Revolution in the 18th century. Methane, another significant greenhouse gas, is 28 to 34 times more potent at trapping heat over a 100-year period than CO2. It's released during the production and transport of coal, oil, and natural gas, and by livestock and other agricultural practices. According to the Global Carbon Project, human activities contributed to about 60% of global methane emissions in the 21st century. Water vapor, though not directly emitted in significant quantities by human activities, is an essential component of the greenhouse effect. As the Earth's atmosphere warms, it's capable of holding more moisture, which in turn traps more heat, creating a feedback loop that intensifies climate change. Nitrous oxide, a byproduct of agricultural and industrial activities, and during combustion of fossil fuels and biomass, also contributes to the warming of the atmosphere. The Intergovernmental Panel on Climate Change states that nitrous oxide is about 300 times more potent than carbon dioxide in terms of its warming potential. Understanding and monitoring these greenhouse gases is paramount. NASA's Orbiting Carbon Observatory 3, launched in 2019, has been measuring atmospheric carbon dioxide with unprecedented detail, aiming to give scientists a better idea of the global carbon cycle and how it's changing over time. Advancements in technology have brought forth cutting-edge tools to combat greenhouse gas emissions. Machine learning, a subset of artificial intelligence, is being deployed to optimize energy consumption, reduce waste, and monitor emissions. The AI for Good Foundation, for instance, is working on machine learning models that can predict and quantify emissions from every power plant worldwide, enabling better regulatory oversight. Beyond mitigation, carbon capture technologies have also been developed to remove CO2 from the atmosphere. These range from natural solutions like deforestation to technological approaches like direct air capture and carbon mineralization. As we step into the next layer of the climate crisis, we must examine the critical role of energy production. The burning of coal, oil, and natural gas for electricity and heat is the largest single source of global greenhouse gas emissions. The International Energy Agency reported in 2020 that energy production accounted for over 73% of total greenhouse gas emissions. The transition towards renewable energy sources is an essential piece of the climate change puzzle. The rise of renewable energy has been extraordinary. In just a decade, from 2010 to 2020, global wind power capacity increased from 198 gigawatts to around 700 gigawatts, according to the Global Wind Energy Council. Solar energy has seen even more dramatic growth, with global capacity soaring almost 17 times in the same time period. This rapid expansion of renewables is due in large part to dramatic reductions in the cost of wind turbines and solar panels, driven by advances in technology and increases in manufacturing scale. Our exploration of energy sources and greenhouse gas emissions brings us to the intersection of agriculture and climate change. Agriculture is both a victim and a contributor to climate change. It's a sector significantly impacted by changing weather patterns and increasing temperatures. Simultaneously, it's responsible for nearly a quarter of all greenhouse gas emissions, according to the Food and Agriculture Organization. These emissions are largely due to methane released by ruminant animals like cows and sheep, nitrous oxide from synthetic fertilizers, and carbon dioxide from deforestation, particularly in tropical regions. The emissions from livestock into perspective. If global livestock were a country, it would be the third largest emitter of greenhouse gases, behind only China and the United States, according to World Resources Institute data. Meanwhile, the Intergovernmental Panel on Climate Change reports that synthetic fertilizers contribute to about 12% of total agricultural greenhouse gas emissions. Their usage has exponentially increased from 14 million metric tons in 1954 to 200 million metric tons in 2015, leading to significant emissions of nitrous oxide, a potent greenhouse gas. Our ever-growing global population, expected to reach nearly 10 billion by 2050, puts immense pressure on agricultural systems to provide enough food. Yet, the way we currently produce food and what we eat plays a pivotal role in driving climate change. To tackle these challenges, scientists, farmers, and innovators are turning to technological solutions and sustainable farming practices. Precision agriculture, powered by AI and data analytics, optimizes the application of fertilizers and water, minimizing waste and reducing emissions. Satellite imagery, IoT sensors, and machine learning models are being used to monitor crop health and yield predictions, allowing for better decision-making. Regenerative agriculture practices, which include techniques like cover cropping, crop rotation, and conservation tillage, improve soil health, enhance biodiversity, and increase carbon sequestration. According to Project Drawdown, a leading resource for climate solutions, widespread adoption of regenerative practices could reduce CO2 emissions by up to 23.2 gigatons by 2050. Plant-based diets and lab-grown meat are gaining traction as ways to reduce the environmental impact of our food system. A study published in the journal Nature found that widespread adoption of plant-based diets could reduce food-related greenhouse gas emissions by up to 70% by 2050. The intersection of climate change and agriculture is complex. However, the transformation in the way we grow our food and what we choose to eat can play a significant role in achieving a sustainable, low-emissions future. As we progress in our understanding of the myriad factors influencing climate change, it's vital to consider the role of deforestation and forest degradation. The world's forests are the lungs of the planet, breathing in carbon dioxide and exhaling oxygen. However, rampant deforestation is compromising their ability to perform this critical function. Global Forest Watch estimates that in 2020 alone, the world lost 12.2 million hectares of tree cover, an area the size of the United Kingdom. This loss isn't just an environmental issue. It has profound social implications, affecting livelihoods, cultures, and the survival of countless species. The Amazon rainforest, often referred to as the planet's green lung, presents a vivid example. In 2020, deforestation in the Amazon surged to a 12-year high, with an area 7 times larger than London cleared of trees, according to Brazil's National Institute for Space Research. This rampant deforestation is pushing the Amazon rainforest closer to a tipping point, where it could irreversibly turn into a savanna, drastically impacting global climate patterns. Forests act as carbon sinks, absorbing CO2 from the atmosphere and storing it in biomass and soils. According to the United Nations Food and Agriculture Organization, the world's forests store about 296 gigatons of carbon in their biomass alone. However, when forests are cut down and burned or left to decay, the stored carbon is released back into the atmosphere, contributing to global greenhouse gas emissions. The World Resources Institute estimates that tropical deforestation accounts for about 8% of the world's annual CO2 emissions. The Intergovernmental Panel on Climate Change states that reducing deforestation is one of the most cost-effective methods to mitigate climate change. But besides this, forests offer a plethora of benefits, from preserving biodiversity and water supplies to providing livelihoods for millions of people worldwide. Technology and innovation are key tools in the battle against deforestation. Remote sensing technologies and satellite imagery, in combination with machine learning algorithms, provide crucial data to monitor and detect deforestation in near real time. Global Forest Watch, an initiative by the World Resources Institute, uses this technology to provide detailed online maps and tools to visualize forest change and degradation worldwide. Another powerful tool is blockchain technology. Platforms like Open Forests by the United Nations are harnessing blockchain for improved transparency and traceability in forest conservation efforts. These technologies can help verify that products are sourced from sustainable forestry, thus incentivizing responsible forest management and reducing illegal logging. Next, we turn to the profound impacts climate change has on biodiversity. The Earth's living organisms form an intricate web of dependencies, with each species playing a role in maintaining the balance of our ecosystems. However, human-induced climate change is disrupting this balance. The IPCC estimates that if global temperatures rise by 1.5 degrees Celsius, 14% of Earth's species will be at risk of extinction. If temperatures increase by 2 degrees Celsius, that figure jumps to 16%. These numbers may seem small, but they represent tens of thousands of species, many of which we may not even know yet. Climate change impacts biodiversity in several ways. Changes in temperature and precipitation patterns can alter the habitats of plants and animals. Rising sea levels can erase coastal habitats, while ocean acidification can devastate marine life, particularly coral reefs, which are home to a quarter of all marine species. Take, for example, the monarch butterfly. These insects embark on an extraordinary 3,000-mile migration from Canada to Mexico each year. But as milkweed plants, the primary food source for monarch caterpillars, decline due to changing weather patterns and land use changes, monarch populations are plummeting. The Xerces Society for Invertebrate Conservation reports that the western monarch butterfly population in California plummeted by 99.9% since the 1980s. Likewise, the 2020 Living Planet report by the World Wildlife Foundation cited a shocking 68% average decline in global vertebrate species populations between 1970 and 2016. The report's findings highlight the urgent need for a global collective effort to halt and reverse the loss of biodiversity. AI is rapidly becoming a powerful tool in biodiversity conservation. Machine learning algorithms are being used to sift through vast quantities of data, from audio recordings of rainforests to images captured by remote camera traps. This allows scientists to monitor wildlife populations, track their movements, and identify threats more efficiently than ever before. WildMe, a non-profit organization, has developed an AI system that can identify individual animals based on their unique markings, similar to a human fingerprint. Using this technology, researchers can track the movements and behavior of individual animals over time, providing valuable insights into their life histories and the threats they face. Meanwhile, the organization Rainforest Connection has developed a system that uses old smartphones, solar panels, and machine learning algorithms to listen for the sounds of illegal logging in the world's rainforests. When the system detects the sound of chainsaws, it alerts local authorities who can intervene and prevent further deforestation. Looking towards the oceans, we see that they play a crucial role in climate regulation. They absorb about 25% of the CO2 that humans emit into the atmosphere, helping to mitigate the impacts of climate change. However, this process is causing ocean acidification, which poses a serious threat to marine life, particularly shell-forming organisms and coral reefs. The acidity of the surface ocean has increased by about 30% since the start of the Industrial Revolution. If current trends continue, it's predicted that the surface waters of the ocean could be nearly 150% more acidic by the end of the century. This would represent a change in ocean acidity faster than any known change in millions of years. Ocean warming, a direct result of climate change, is another significant threat. The International Union for Conservation of Nature reports that more than 90% of the excess heat trapped by greenhouse gases is absorbed by the ocean. This has led to increased sea temperatures, which can lead to coral bleaching and disrupt marine ecosystems. Melting polar ice due to rising temperatures is also a major concern. Satellite measurements show that the Greenland and Antarctic ice sheets have been losing mass. The World Meteorological Organization reports that in the decade from 2006 to 2016, the Greenland ice sheet lost an average of 278 gigatons of ice per year, while the Antarctic ice sheet lost about 155 gigatons per year. If all of Greenland's ice were to melt, it would cause global sea levels to rise by 20 feet. The El Niño Southern Oscillation is a natural climatic phenomenon characterized by fluctuations in temperature between the ocean and atmosphere in the east-central equatorial Pacific. The warm phase is known as El Niño, while the cold phase is La Niña. This year, meteorologists reported one of the strongest El Niño events in recorded history, with the temperature of the surface water in the Pacific Ocean rising significantly above average levels. This extreme weather event, much like the El Niño of 1997 to 98 and 2015-16, had significant implications for weather patterns and climate phenomena globally. El Niño events can exacerbate global warming trends. According to the National Centers for Environmental Information, the El Niño event of 2015-16 played a major role in making 2016 one of the warmest years on record at the time. The same could be true for the extraordinary 2023 event, potentially making this year one of the hottest yet. El Niño events significantly impact global weather patterns, causing extreme weather events like floods and droughts. For instance, regions such as the southern United States and Peru often experience heavy rainfall and increased risk of floods, while Australia and parts of Southeast Asia are more likely to experience drought. Moving from the oceans to the atmosphere, one of the significant yet less known contributors to climate change is short-lived climate pollutants. These include black carbon, methane, tropospheric ozone, and hydrofluorocarbons. Although these pollutants stay in the atmosphere for a much shorter time than CO2, hence their name, they can be much more potent in terms of their heat-trapping capabilities. According to the Climate and Clean Air Coalition, reducing emissions of these pollutants could reduce global warming by up to 0.6 degrees Celsius by 2050. Such reductions would also have significant health benefits, as these pollutants are responsible for millions of premature deaths each year due to air pollution. Their initiatives range from reducing methane emissions in the oil and gas sector, mitigating black carbon produced by brick kilns, to promoting alternatives to hydrofluorocarbons used in refrigeration and air conditioning. Speaking of these HFCs, these are potent greenhouse gases that are used in air conditioners, refrigerators, and other cooling equipment. They were introduced as a safer alternative to ozone-depleting substances, but we now know that they are powerful climate forces, with a global warming potential up to 9,000 times greater than CO2. The good news is that in 2016, the Kigali Amendment to the Montreal Protocol was adopted, with the goal of cutting the production and consumption of HFCs globally. The United Nations Environment Programme estimates that full implementation of the amendment could avoid up to 0.4 degrees Celsius of global warming by the end of the century. As we can see, the mitigation of climate change is a complex and multifaceted challenge. It requires us to look beyond the usual suspects, like CO2, and consider a range of other factors and contributors. But with a combination of international cooperation, policy interventions, technological innovation, and individual action, it's a challenge that we can meet. One such area where technology and innovation are rapidly transforming the landscape is renewable energy. According to the International Renewable Energy Agency, renewable energy accounted for over a third of the world's total installed power capacity in 2020. Solar power has been at the forefront of this revolution. In the last decade, the cost of solar photovoltaic modules has fallen by around 80%. This cost reduction has been driven by advances in technology, economies of scale, and increased competition. The trend is clear. The World Energy Outlook of 2020 by the International Energy Agency suggests that solar power is set to dominate future deployments, becoming the new king of the world's electricity markets. Wind power is another renewable energy source that has experienced remarkable growth. Data shows that the total installed wind power capacity has grown from just over 24 gigawatts in 2001 to over 651 gigawatts in 2020. Offshore wind power, although starting from a smaller base, is also set to expand dramatically. According to the IEA, if policies and investments continue to evolve favorably, offshore wind could become a $1 trillion industry by 2040. Another key area for a sustainable future is the concept of carbon capture, utilization, and storage. As the name suggests, this technology involves capturing carbon dioxide from point sources or directly from the atmosphere, utilizing it for industrial purposes, or storing it underground. In terms of utilization, captured CO2 can be used in a variety of ways. It can be injected into depleted oil and gas fields to enhance recovery, used in the production of chemicals and fuels, or even incorporated into building materials. For example, the company Carbon Cure Technologies has developed a process that introduces recycled CO2 into fresh concrete, where it becomes permanently embedded, reducing the carbon footprint of the concrete. As Carl Sagan once said, we have the power to influence, to avert, to mitigate. Earth is a place to be saved as well as studied. We wish to emphasize that while the challenges are immense, so too are the opportunities. In every challenge, we see the potential for innovation, resilience, and the power of collective action. We must confront this crisis with a spirit of hope and determination, backed by the best of our scientific understanding and technological capabilities. The work to be done is no less than the preservation of our planet, but together, we can build a sustainable, prosperous future. As viewers, your understanding, empathy, and action are critical parts of this process. Thank you for joining us on this journey. We hope it has been informative, enlightening, and inspiring. And as always, stay curious, keep exploring, and let's dive into the mysteries of the universe together.